Green Mars is no longer science fiction. Scientists have presented a terraforming plan from melting ice to creating an atmosphere. Mars is indeed a planet similar to Earth in many ways, despite its differences such as a thin atmosphere and colder climate, but it does have a number of similarities, including the length of a day, the tilt of its axis of rotation causing the seasons, and similarities in landscapes formed by ice. The prospect of terraforming Mars, which seemed like science fiction 3 decades ago, is now becoming a reality thanks to modern capabilities and research in this area. Scientists have presented a step-by-step plan for turning the red planet into a potentially habitable world, relying on modern technologies, including the Super Heavy rocket Starship from SpaceX. Despite the difficulties in its development, the very fact of creating such a device opens up opportunities for the delivery of cargo and the implementation of large-scale projects beyond Earth. The first stage involves increasing the average temperature of Mars by 30 degrees Celsius, which will lead to the melting of subsurface ice and the formation of a global ocean up to 300 meters deep. To achieve this, the authors propose deploying giant solar sails in orbit, which, like mirrors, will focus sunlight on the planet's polar caps. An additional greenhouse effect will be created by aerosols sprayed into the atmosphere, and silicate aerogels covering areas of the surface will provide local heating. According to calculations, the implementation of this stage will take about a century. The second step involves introducing genetically modified extremophiles, microorganisms that survive in extreme conditions. These pioneer species would be released into the saltwater bodies left behind by melting ice to alter the environment's chemistry and pave the way for complex ecosystems. The final and longest stage involves creating an atmosphere with an oxygen level of 100 millibars, 10% of Earth's level. Initially, oxygen would be produced in giant domes up to 100 meters high, where plants would be able to survive. Over time, they would spread beyond the shelters, gradually enriching the atmosphere, but the process would take millennia. It could be sped up by extracting oxygen from meltwater, but this would require confirmation that Mars has sufficient reserves of the necessary resources. The authors emphasize that terraforming Mars is associated with ethical and scientific dilemmas. Transforming the planet could erase traces of its natural evolution, depriving humanity of unique data on the past of the solar system. In addition, the success of the project depends on breakthroughs in technology, including the proven operability of Starship for regular flights to Mars. Despite the ambitiousness of the plan, the researchers are confident that the path to a green Mars is getting closer. However, before starting a global transformation, it is necessary to carefully weigh all the risks and consequences.